Oh, so you just want to learn, right? Yeah, that's something definitely you may encounter in that.
Maybe I will use it later, but now I'm like.
All right, welcome to today's session. The topic for today is how to parallel your serial tasks with GNUParallel. All right, before I start, I would like to get just to see find out why you come to this session, what kind of ideas in your mind, what do you want to parallelize to? Right, Jeff?
Well, I need to use my work for analyzing computer,
Uh-huh.
all sources I can, and to speed up my work.
Right. Okay. And you have a lot of small serial tasks. Okay. Sir? Oh, so you just want to learn, right? Yeah, that's something definitely you may encounter in that.
Maybe I will use it later, but now I'm not here.
Okay. Okay, that's perfectly fine. That's perfectly fine. You?
Yeah, I'm in the same situation.
Yeah.
That's
Okay. All right. All right. That's perfectly okay. Yes, ma'am.
I plan to provide optimization, structure model, type optimization, generate the scalar structure, inside scalar structure, with some parallel structure can be provided.
Okay, but basically, okay, so basically your current application is serial or portion that you can parallelize? Is that what you're saying?
Function, yeah, function.
Okay. All right. And then when you run your application, do you have, for example, you have different parameters you want to test, the same application, but you have to run many times? Is that what you're trying to do?
Mm-hmm.
Or just the one application I run once and that's it, I get my result?
Actually, parameters has decided just one application.
Uh-huh. Okay. All right. Cool. Sir?
Like everyone else, I'm here to learn.
Mm-hmm.
I have an application
Right.
that runs essentially in serial mode.
Right.
Processes a large quantity of data, and I want to run it multiple times.
Perfect candidate.
But it's almost always the same parameters.
Mm-hmm. Yeah. And I know there are quite several groups in biology. They have basically their applications are serial in nature, but they have so many, maybe because of different parameters they have to test or different scenarios. So they have to run the same application with different input thousands and millions of times. And then if you do one at a time, that'll take you what? For a postdoc? It'll take you 3 years to run one job, right? All right, so great. Now, okay, let me make sure. Okay, so this is the overview of what I'm going to cover today. And generally I will tell you why we're right now in this situation, what's the problem. And then I will, to encounter the problem to solve the issues, now we're going to use GNUParallel. And I'm going to give you a short introduction and some options, how to use GNUParallel. And also I'm going to give you 3 examples, different type of real-time applications, how to use GNUParallel to facilitate the simulations. All right. So now, these days, it's so exciting. We have HPC clusters everywhere. Here at LSU, we have several clusters, SuperMIC, SuperMIC, and also Lonnie as well, Kunbi, right? Then the difference of the HPC clusters and then your laptops is now the HPC clusters has many thousands of millions of cores. Then you have your own application. Those many nodes have different cores. Could be 8 cores, 16 cores, 20 cores, and even 48 cores for HPC at LSU. So it really depends on the system. You can get really strong computational resources. Then the question is, now we have these supercomputing resources, then you have a serial task. How you can really effectively to use the power machines to facilitate your research? And this is a question that can be very challenging, and I guess that's something that we'll have to deal with, right? Now, this is the basic problem. Now you have a lot of input, okay? You have a lot of data, and I have the same application. I want to process all those data, okay? Like the same application, and if I run one application at a time, that'll take, you can do the calculation. Now you take one data and you generate one output. So if you do this in serial mode, that'll take quite some time. However, we want to parallelize this process. Oh, before we get into GNUParallel, I want to give you some examples of what users might do. And this is what they have been doing. They have tried. Okay, let's look at this scenario. This is a blast. It doesn't really matter which application I'm using, which example I'm using. This is a blast it's kind of a sequence, genome sequence. Blast, okay, so here I'm using, because this application is a serial, basically using one core. Okay, so I have look at the last line. I have a blast, I have a query, that's my input, and I have a database, I have output. Okay, so this is one job. I'm going to submit this one job to HPC cluster. All right, good, that's perfect. And then I have another input. Okay, so the input 2, and that is input 1. So I have to submit another job. Everything else stays the same except the input. And also, of course, output going to be different as well, right? This is perfect, but this is what, if you don't know how to parallelize your serial code, this is how you're going to do it. All right, so essentially you need to submit n jobs if you have n different input. Does it make sense? Okay. This is fine. It's going to be slow, but it works. All right, so that was using one core. All right, so now this user, the second user comes in and said, okay, I want to be a little bit more sophisticated. Now I'm going to use one node. This one node, I'm on Supermind, for example, on this one. One node has 16 cores. So basically, I should be able to run 16 jobs at a time, okay? So this user 2 is a little better. Now look at the middle part, the bold session. Now you can see, okay, I have, basically it's the same command, right? I have blast and a query, and I have 16 of them. And I put each one into background. That means, okay, my job 1, my first task will take the first core. My second task will take the second core on this node. So forth, until the 16 jobs all submitted to the background to occupy the 16 cores. So the 16 tasks can be executed at the same time. And at the very end, there's a command called wait. Means, okay, I'm not going to exit this application until all the 16 tasks are finished. Okay, this is one way. It's much better than the first approach, right? Yeah, you could do this way. All right. So the problem with this one is only one single node can be used, right? And the same command syntax with a different input is better, but it still can be improved. All right, what about if I want to use more than one node? I want to use 2 nodes, 10 nodes, okay? 64 nodes, for example. And what happens is if you request, for example, 10 nodes, the first node is mother superior. And the rest are just the slave nodes, basically. So this is a little bit just kind of knowledge that you might like to know for PBS system. So basically, only the mother superior has this node. Only the first node has the information about all the job information. Okay, about all the environment. Only this mother superior has the information, and all the slave nodes will be managed by this mother superior. And then basically the mother superior will connect to the each compute nodes by using SSH. We'll look at this. All right, so this is a third user. So this guy has requested two nodes. If you see at the top, right? Two nodes. And then what happens? Okay, now on the mother superior, I'm going to submit here. I put down eight tasks. It's fine. Okay, but then I have the second node. So what it happens is the mother superior will start SSH. Okay, we'll tell all the rest of the slave nodes, do this, do this, do this. So can you see this is getting really complicated? All right, you don't want to get into this. I don't do this either. Oh, you can get really messy really fast. And this is only 2 nodes. What if you have 10 nodes? Okay, your script would be hundreds of lines long and it will be errors everywhere, error messages everywhere. So this is not the way to go. But however, yeah, you can use more than one node by doing this. All right, so we need some solutions, right? We need to fix this problem. I have serial tasks, and I'm going to talk about what kind of applications that we can use GNUParallel. So we have serial tasks, and we want a solution that can help me to parallelly submit those individual jobs, okay? And I want really minimum customization. I don't want to do a whole lot. When I use a tool, I want it easy to use. I don't want to have to learn for a month how to use that tool. No, that's not what I want to do. So I want a solution that I can work with and it can be very effective. All right, now comes GNUParallel. GNUParallel is not the only tool, but it's I've been using it for quite a number of years, and I found out this tool is really easy to use and has a big community. GNU, right? You know, GNU compiler is a big community supporting it, developing it. It's just a phenomenon. And WQ actually, quite a number of groups at LSU were using WQ. WQ was a kind of software written in Python. It's a job dispatcher to submit serial jobs in parallel. That was designed in the house by our group. However, it's it lacks support and is hard to use, especially initially. So, and GNUParallel is a much better tool, and it's so much easier to learn. So this tool is a shell tool, okay, to execute independent, that's important, independent. So those jobs are not related. They don't need information from each other. So they're independent jobs in parallel using one or multiple nodes, okay? And the job can be a single command, can be a script, right? Could be anything. And input could be a list of your task, your list of your input, list of your different parameters. Or I can, yeah, that's it. Yeah, you can put that into a file. So what happened under the hood when you use GNUParallel is the SS session connection will be started by the mother superior. So the mother superior will start SSH connection to each slave nodes and telling the slave nodes, okay, you have one job, you have. So that's how it manages. All right, so on HPC clusters, now on SuperMic, we have this key, okay? So if you want to use GNUParallel, add this key to your home.soft file. We can talk about that detail if you get confused a little bit, if you haven't used that. But this is how you can make sure every time you log into your system, the GNUParallel is there ready for you. Or you can just manually, once you get into a terminal, you can manually add this key, all right? So on QuickBee and SMIC, we're using modules instead of soft env. So for those two systems, you need to do module load GNU parallel. So it's the same thing. It's basically to bring GNU parallel to your working environment. And you can check your version just by after you bring in your GNU parallel, the software package, and you can do parallel version and it just make sure because it was so funny because GNU parallel has released so many versions. Previously, when I was using it, there was a big bug. It really was annoying. I think you had the same problem too. So don't use the version that you installed by yourself. The problem is, for example, a node has 16 cores. And the previous older version of GNU parallel, no matter what parameters you tell the GNU parallel, use all the cores on the node. It will not. It only use up to 9 or 10 cores. So leave the rest of the cores idle. And that's the bug in the older version of GNU parallel. But now the newer versions have solved this problem, which is fantastic. All right, here I'm going to just, I don't expect you to understand this, but I'm just going to throw out, okay, this is my serial task, all right? So I have a bash, I export my data directory, and I'm going to run this command. That's a blast, right? Could be anything. Could be docking, or it could be anything that you're using, right? But here is just a blast. And then you can see the query now, instead of a real input file, I have a $1, which means this query will be passed into this file, okay? And everything stays the same. The output is as well has to be changed according to the input. And look at the bottom box. This is my input file, all right? I have a file called input list. Could be anything you specify, all right? And in that input list, I give a list of the input task, input parameter, or input files that I want to use. So each time one line task 33 will be put into that $1 spot, okay? Don't worry, you may not really fully understand by now. It's okay. I just want to throw out a sample here. And here, okay, that was basically the serial task. And here is my typical job submission script. Okay, so here what I did is I have export jobs per node. I specify 16. This is my super mic, right? So I have 16 cores. So I want this job submission script to run 16 tasks on each node. I apply 2 nodes. So basically I can run 32 tasks when I submit this job. And I define the parallel with all the different parameters. We'll talk about this in this tutorial, but just say that I defined parallel, the capital parallel. It's just a variable in my bash, right? You have learned bash. I can define variables. I define that variable as all that string basically is the parameters that given to that I use with the GNU parallel. And then I'm going to call the GNU parallel -a. I'm going to give the input. And I'm going to run my script. The script is the one slides before. I'm going to sh run blast. And open close curly bracket is where please give me the jobs from the input list. Put in here, sent to the yes. Work dir? Oh, there was a typo. Typo, yeah. It's the same, yeah. Yeah. I didn't catch that. I think the later slides, I changed it. It's the same. It's the same, right? It's a WDR, it's a work DR, WDR, yeah. I was using short term. And then I have the output, and I also passing to that to my serial task. All right, it doesn't matter. You are not getting it right now. I assume but that's why we're here. Okay, we're going through all this. So basically, now with this script and the little script before, you can submit. You can have 32 jobs running at a time instead of one job, one task. All right. Oh, here. So I did a little performance comparison. What I did is, okay, I requested one core, and also I requested nodes from one node all the way to 64 nodes. Okay, I have 1,000 serial blast tasks, and I want to see how fast I can finish my job using GNUParallel. All right, so look at this. If I use only one core, basically Blast is a serial code, right? Serial application. So one core for 1,000 tasks, independent tasks, it took me over a day. Okay, over a day. And then, all right, this because that one takes so much time. This graph is kind of it's hard to read. So I put down one node, 2, 4, 8, 63, all the way to 64. Another graph. Now you can see then when I use one node, okay, 16 cores, it takes about 3 hours, not quite 3 hours, from over a day to 3 hours. And then when I go all the way to 64 nodes, it took about 20, about 5 minutes, not even 5 minutes. Is it 5 minutes? That's minutes, okay? So that's 10, no, it's about 5, yeah, 10 minutes? Yeah, it's less than 10 minutes. Yeah. So all the way from over a day to less 10 minutes. It's pretty impressive. Okay. And I guess in your research, you would like to get your job done as quick as possible so that you can investigate whether this approach is my approach is, you want to get a result as soon as possible. All right. Now we get into GNUParallel, the syntax. Keep in mind, it's a really easy tool, okay? You just need to understand several options or flags, and then you can start get going. Okay, the basic syntax, basically think about GNUParallel. It's you have not one task. You want to use GNUParallel to process multiple tasks, right? So the task is a list, is a list. So GNUParallel basically is taking one item from that list, take another item from another list, and to send those jobs to different cores, right? So parallel, that's the command for GNUParallel at the options. And I want to run the command. Command could be anything. Could be your script, could be, right? Your application could be Blast. And then that curly bracket would be, gave me one list, one item from the list, put in there, and then as a parameter sent to my command, okay? Because all your command would need some kind of parameters. You cannot just run without parameters. And then if this list coming from command line, then you can do 3 : ::::, and a task list. I'll give you example. You might be confused right now. And the next one is, okay, most of the times when we submit jobs, it's not from command line, your list. The list is in a file, right? That's normally how we do it. We always put all our parameters in one file. And this file may have hundreds of lines long, which means hundreds of different tasks, right? And then if that's the case, the only difference, instead of 3 columns, I have 4 columns. However, I'm not prefer that way. So I would use -A, task list. This is my preferred way. Okay, -A and task list. That means that is telling GNUParallel, this is my task list. Okay, and the rest stays the same. We'll have examples, so don't worry. All right, so let's look at several examples. All right, so here I use parallel, right? GNUParallel, and my command is echo. We all know echo, right? Echo is just to reflect what you typed in, to the screen. And I have a curly bracket. That means, okay, I need parameter from my list. My list is A and B. So then my result is A and B. This is in parallel. Actually, this was done in parallel. Next one. Okay, for my echo, I want to give it 2 parameters. GNUParallel lets you to have more than 1 parameters passing into your command or your script. So I can do echo. This echo could be anything. I'm using echo as an example. So echo, curly bracket 1 and 2, and then I need 2 sets of parameters coming in, right? Because I'm asking for 2 different parameters to pass into echo, so I need 2 sets of input. So what's the result for doing this? It'll be AC, AD, BC, BD, all the combinations. Is this what you want?
It's just like a query input.
Not comparing, is putting out. It's taking one from the list and putting it out. Right. This is actually not what you want, because I want my, I have 2 lists here. I want the the list from the item from the first one and the first one from the second, and put them together as my first. Normally, that's what I want to do, right? So if that's what you want to do, you need another flag here, link, dash dash link. Look at the result, it's different now. So basically, I'm taking the first item from the list 1 and the first item from list 2 as my parameter for my first command. This is what most people would like to do, right? I have 2 lists, 2 job tasks. And I'm going to take one here, one here, one here. I don't want all the combinations. You may want all the combinations, but it's up to your application, right? So if you want to only have, has an order, then you would use a link. All right, so this is just the same thing, but with a different, instead of using echo, I'm using application XXX. Could be anything, basically. It's a placeholder. And I have all that. So what's happening with GNUParallel is your application will take A1 and B1 as parameters passing in, and application, the same application, will take, the second one would take A2 and a B2 to run your simulation. Those are just placeholders. All right. Now, before was it coming, the list coming from a command line. Now, most of the times when we submit jobs, we need to put our tasks, our input into a file. And this is the format. I prefer the first one, -A. Okay. If you have multiple input files, -A input file 1, -A input file 2. All right, example. I have this file, okay, parallel -A, that means I have an input list, CSV file, this file, and echo. It's an example, okay? Echo just means whatever in that list, just print it out, the screen, okay? Could be anything. And this is my file. This file contains only 2 lines, 1 comma input, 2 comma input, okay? So if you do this, you're going to get output like that. All right. So GNUParallel has a really nice feature. If you have a file that has different parameters separated by comma or tab, and you can tell GNUParallel -- column sep, and give it pattern, either comma or tab, and GNUParallel will separate the first line as 2 parameters as 2 values at 2 different parameters. So now look at this. If you say echo 1, right now it only prints out 1, okay, and a 2. And only when I do echo 1, 2, it's print out the whole thing. So now you're basically, the way you give parameters, you have 2 lists, give to your application, right? Or you can put all your parameters in 1 file and separate it by column, by comma, or tab, or anything, right? And then when you run your GNUParallel, just tell, okay, using that separator, the eliminator, to separate all my different parameters for 1 task. So make your life easier. If you get confused, we can talk more after class. It's just easier. Instead of giving multiple lists, you can have a one list putting all your different parameters, because your application may need 3 parameters, right? Instead of using 3 different lists, you can put all 3 parameters in one list, but each value separate by a something, by a special character that you prefer. All right, now, so curly bracket tells GNUParallel take items from the list, right? And when you have the curly bracket, by default, you take the whole thing from the list. Okay? All right, so my input is a path input FASTA, okay, file. And the output here would be just taking the whole thing, okay, including the path, including the name of the file. However, sometimes I do not want to have the file extension because I want to change it for whatever reason, right? So you can use curly bracket with a dot in the middle. And look at that, the output would be the whole thing, but the file extension. This is how you can manipulate your input output. It's really, really great. Another way, I don't want to have a path. I only want to have the file name. Use slash. Now the input original format is that. Now I only get the file name. No path, if that's what you want to do. But remember, by default, the whole path and the file name will be used. I'll show you why I'm talking about this, okay? And now this one is remove path and extension. I only want to have my file name without anything, without extension, without the path, because I may want to change this as my output. I put input1.out, right? That's easily manipulated. All right, here is the example here. I want to change extension and a path. All right, so here, instead of using curly bracket, I'm put output there, output backslash, and then in this curly bracket, I remove the path, I remove the extension, and then add .out. So the same input, now look at output. It's going to be output input1.out. Why am I doing this? A lot of times when you have input, the input is path input1 FASTA, right? That's the input file. But you always get result. Your result, you don't want input1 anymore. You want input1.out. You want a file to hold your output. That's all simulations you have to have output, right? And somehow you want for each task have the equivalent output. This is the really fast way to get that done. We can talk more if you get confused. All right. So that was the how GNUParallel process the different items from the list, from your tasks, right? And here are some options that goes with the GNUParallel. I'm going to mention about this one by one. Jobs, as the SSH logging file, work directory, progress, job log, and timeout. Some of them are very useful, and I don't have to use them, all of them. Just use the ones that you think appropriate for your task. All right, this one is super important. Jobs, -- jobs. You're telling GNUParallel how many independent tasks you want GNUParallel to run on each node. Okay, so for SuperMic, I have 16 cores on each node. I'm telling if I say jobs 4, that means please run 4 jobs on each node. That means what? Each task will use 4 cores. Or I can say jobs 16, please run 16 tasks on each node. So 1 core, 1 task. Yeah, if you don't specify that, that would mean as many possible. But for you, you want to have a control. You want to really specify, I want 16 jobs, I want 8 jobs. But if you leave it, it'll be use as many cores as possible. If you're 16 cores, GNU-Parallel will start 16 jobs on that single node. But if you really want to make sure, okay, I want to really specify, I want 16 tasks, I want 8 tasks, or however many. And there's another option, plus minus n means, I don't know, it's just option, you can do that. More than one task than the cores a node has, or one less tasks than the cores that a node has. It's just has option, but who would do that, right? And also make sure use GNU-Parallel version greater than that. If you use earlier version of GNU-Parallel, your GNU-Parallel will not use all the cores on the node. And that's why you had to do all the manipulations to create your machine list. That's crazy. All right, this one is --SLF. It's SSH login file. And you use this flag when you have requested more than one node. Because you need to tell GNU-Parallel, now not only I have one node, I have all these different nodes here. You have to tell GNU-Parallel. GNU-Parallel doesn't know anything unless you tell GNU-Parallel what to do. So for this, a lot of times you would use PBS node file. That's a global variable that is given there when you request a job. That global variable is internal variable used by PBS. And that holds information about your machine names, all that. So for example, if you cat, after you submit a job, you're sitting, you have to submit an interactive job. You're sitting on the mother superior node. And then if you say cat PBS node file, you would see the list. Okay? So a lot of times, if you request more than one node, you would have to specify --SLF PBS node file. Job log. This is really critical. It's really useful, actually. And basically, if you specify this flag, GNU-Parallel will keep a log file. It will keep a record. Which task, because you may have thousands of jobs, right? We'll keep a record which task has been finished. Isn't that useful? You really need that. Basically, you can identify failed tasks, right? Sometimes your job just being terminated for no reason or some reason, and you want to know which task I don't have to repeat anymore. I don't want to repeat every time from 1,000 tasks. I want to only redo the ones that I haven't done, right? So this is a critical flag. And also, I'm going to talk about that. If you combine with resume flag, it'll automatically next time pick up where it's left off before, finish the rest task. This is really cool. I love that. Otherwise, before, when I was doing this, I would have to really look which one has been done, which output file is there. And I have input, I have output, and the output, of course, if it's less than input, I have to find out which one has not been done. I have to manually create another list. Okay, now I submit another job to finish the rest, which is, it's feasible, but it's not pleasant. But this can be done automatically, which is a very cool feature. Oh, resume. All right. This is fantastic. If you combine resume with a job log, you really have to have a job log, okay? Because the resume will look into this file, see what has been done, what has not been done. And if you combine these two together, we allow GNU-Parallel to resume a job that has been unfinished for whatever reason. Failure, timeout, whatever. However, a caveat here. If you have your previous job log file staying there, and the next time I want to, for whatever reason, I want to restart this whole thing, okay? I have 1,000 tasks, I want to restart it. If you still have the old log file there, it's not going to restart because this thing is done, right? So you need to remove that file and then start from the beginning. Yeah. So just keep that in mind next time. Because I don't know why my job is not running, because you've done, right? Another flag here is a progress. And this could be useful. It's really up to you. Basically, if you specify progress, when you start running, it'll show you, okay, I have this many machines, and I have this task running on this machine, that task running on that machine. It just give you some information about your job running situation. So it's nice to have, but not necessary. Timeout, pretty obvious, right? If you know your job normally finish in 2 hours, and you set this up, and some tasks for whatever reason never finish, and if you don't have this timeout there, and that task will just keep trying and trying, right? So it's basically to save the resources, and you can use it. You don't have to use it. This is an optional. And there are several other options that I'm not going in. It's just to, for example, you can check the load. If the currently load is too high, and then the GNUParallel may not even submit a job. We'll wait. And also no swap. If the swapping, there's too much memory paging out in and out from the hard drive, and then no swapping would be a flag to use. And the memory free, if, for example, if my job takes a lot of memory, requires this much memory to run the task, so you can give a flag, say, okay, I need this much memory to start the next job. If there's not enough memory, don't start. So those are just optional, and there are even more other options, flags that GNUParallel takes. So if you're interested, you can always find more information, but those are optional. And the most, I think, important ones would be jobs, the number of jobs you want to run on each node. And the job log, that's very important. Resume, if you want to have that, that's important. I love that. And also the logging file, right? SLF, logging file, that's very, SS logging file, that's important if you have more than one node requested. Yeah. Okay, what time is it now? All right, we're good. We're in good shape. We're going to get off early today. And at the rest of the session, I am going to give you 3 examples how we're going to use GNUParallel to submit serial tasks for 3 different scenarios. Okay, the first one is serial task. Basically, it's one core. It's, for example, BLAST. Actually, BLAST can use multiple cores, but if you specify one core, I can just think it's a one core task, right? So the serial task and the multi-threaded jobs, actually, this is not really serial task at all, but to give you this possibility, even your application using multiple cores, which means it's not really serial, it's parallel application already. But you still can use GNUParallel to have many applications running, many tasks running, right? And the last one is MPI. Heard about MPI? Okay. Well, some of you may have, some may not, but it doesn't matter if you haven't, that you're not using it. MPI is a message passing. MPI message passing interface. Yeah. So those jobs, those applications actually can use or designed to use many nodes, multiple nodes, and the messaging will passing through different cores on different nodes. And basically, this kind of applications are parallel, right? It's not serial anymore. However, GNUParallel will let you to submit multiple of those tasks as well. So my title for today's talk is how to parallel your serial task. It's not that accurate, basically. GNUParallel actually lets you parallel real serial tasks, multi-threaded, which is not, tasks, and also MPI jobs. This basically can can do them all. All right, the first one, serial. This is the one that I gave you, the very beginning, I gave you throughout the two script. That was a serial task. We'll look into that. So basic command, okay, could be anything. I'm using BLAST application as example, but for you, you could be Autodoc Vina, and you could be, what were you using?
Gypsy.
Gypsy, okay, Gypsy. And whatever you're designing your code or optimize your code, that BLAST P could be your application, okay? And I have my input is a query, because I want to query this input FASTA file against the database. My database is there, okay? I have a big database, so I have query to sequence against that database. And then number of threads. For this one, I'm using just one thread. You just pretend this is serial. Actually, it's not really completely serial task. All right, so I am going to, so you've seen this before, right? This is my serial task. If I only want to blast one query against the database, this is what I need to do. However, the $1 and $2 needs to be replaced, right? $1 would be my input. For example, would be my first input in this input list would be test33.faa. That will go into $1. And $2, what's going there? It's going to be all the paths, and then no, it's not going to be. You look at what $2 is. $2 would be something that I want to put my output into output folder, and I will change the file extension from FAA to .out. So that makes my application flexible. All right, now this is my job submission script. Now we can look at, we should be able to understand this a little better right now. The beginning, those are PBS directives. You've all seen that, right? Because when you submit a job, all those have to be there. I have notes. I've applied for 2 notes. Wall time could be up to you, up to 72 hours typically. And I have my location. I want to submit to work queue and all that. Yeah, I do have a typo there. Work dir is the same as the WDIR.
So
yeah,
you use the work directory, the $WDIR. So when you have it, you mentioned the author, is that how you do that?
Hold on. Let me just change it on the fly. I have a typo here. Here we go. That's the same question that Xiaoxu brought it up. Oops, back. All right, now does it make sense? Okay, it was a typo. All right, so I'm exporting W work dir as this, okay? For you, you could be different. And then I'm cd to this directory. Because remember, you really have to make sure when you submit a job, if you have multiple nodes, it really doesn't know where to start. Basically start at the home directory. So if you don't specify cd to that work directory, it'll stay in home directory. All the files are not available. So because your files could be sitting in that specific directory, so you have to make sure you cd to your work directory, okay? And a lot of the times the work directory might be your job submission directory. You can use PBS or work dir, right? But that's a different story. And then next one, I export jobs per node as 16. Now you understand that? So look at the next line, parallel. When I define parallel, this variable, I have a -j as a jobs, okay? I'm putting that variable there. Means, okay, GNUParallel, listen, I'm going to ask you to submit to have 16 tasks, because that variable will replace by 16, right? 16 tasks on each node. Now I request for 2 nodes, so I will have 32 tasks running at the same time. All right, and then I have another flag Now you know that one, SLF. Okay, I'm telling GNU Parallel, okay, use this variable because this variable holds information about the nodes you have requested. You would not know ahead of time because it's up to PBS, right? Whichever node is available. So that variable is available on the fly, only after you get your job submitted. Okay, get your resources, and that variable will be filled in with the real machine name. Now, work directly, www --wd. I don't know why I'm messing that up here. I don't want to confuse you. I'm going to change the slides online as well. Okay, so the same one, WD. What is this WD good? This one is really important, WD. Normally, when the mother superior, remember, to set up SS connection to the slave nodes, okay? So the task will start at the login level, which is your home directory. If you specify this, that means, okay, go, it tells GNU Parallel, all the slave nodes will start in that directory. Okay, this is very important because all your files are sitting in this directory, right? And then job log. This is super important. I want to put my job log in this directory. You have the log directory already. I want to specify as a run task log, right? And then I do resume. You can have it, it's option. And then I define this parameter, and then I'm going to call that parameter. So when I do a $parallel, which means everything will be substituted, right? The whole big string will be substituted there. And now I have my input. Input is input.list. And what's in that list is over there. Okay? You have to have that list. And you know all those files, based on your application, you know those files are sitting there with your different input parameters. And then my real application is I'm going to run blast, which is the script in the previous slide. And then a curly bracket, it means take items from this list as the parameter with a run blast. That's my first parameter. However, I have another one, okay? Another one here, look at the define, the format. I'm using output / remove the path of my input and remove the file extension from the input and adding .out. This whole thing as the output name for each task. If I go back, one more slide, you see that $2? That's the $2 right there.
Why do you need the input list twice? So if
not twice, just one.
Blast at S8
oh, you mean this?
Yeah.
Okay, because where are you going? Depends on your application. Where do you put your output file? I don't have to do it this way. It could be any other way. Where would you put your file? You want to redirect your output? Yeah, just tell me your application.
Yeah, it generates its own output in a structured folder.
In the structure folder. And then you have to specify that.
Right.
Yeah, it's because and also you want to use different names, right?
Right.
Because right now it's not running one thing. It doesn't matter, it automatically going to the output or with a certain name, right? Automatically. Right. However, if you have a 10 task running, you wouldn't want to mess up the output. Will we all having the same name?
Well, okay, but my question is this: string one. String one is reading.
The $1. Are you
talking
about
$1?
$1. The first item on that list, in that list.
Okay.
Yeah.
Okay. I understand.
And then the $2 would be modified version of this input file.
Right.
Because I want to.
The output, right?
Yes, I want each input have corresponding output. Now, if you understand this, so you come back here, you see my output. I'm changing, formatting, kind of redesigning.
So $1 is input list.
Yes.
$2 is output.
Yeah. Yeah. And see, when every time after GNU parallel, you see curly bracket. That curly bracket means getting the item from the list.
Input list.
From the input list, yes, from the input list. And using, I have two, that means my single task needs two parameters. The first one and the second one. And it could be third one. Okay? And for this one, actually, I only have an input, basically one input. What if applications, I need three inputs? It could be, right? Three different inputs. And I would have to have run blast, run your application, curly bracket, curly bracket, curly bracket. And I have 3-A, input list 1, input list 2, input list 3. And then you can also combine those three different parameters into one file, remember? You can use a different flag, you mean dash, column, sep, and it can tell GNUParallel, separate those three different things.
Did you have a conditional input?
For example,
There was a change, like let's say an instrument change that occurred at a certain point in time.
in the middle of a run. That's kind of interesting. How would you do that right now?
Program it manually.
So if somehow in the middle of a run, a single task, right?
Yeah, as it's
And
going through the data at a certain point in time, an instrument changed, and it has to now use a different parameter.
Different parameter file. Okay, that different parameter file can be predefined. Then give it input as a second parameter. You put the
So in the
yes, initially you just pass in two.
shell script, then
Yeah.
you would write the condition in there.
No, you don't. You don't. You basically pass two sets of parameters. Okay. One is for your current run and one for your conditional parameter.
Okay.
And within your application, because you have two parameters already, and if the condition is met, and then you're taking the second parameter.
Okay.
That's easy. Right? Yeah, that'll make you, just passing two, just in case condition.
4, 5.
Yeah, 4 or 5, yeah. Yeah. I think we're going to shall we take a break, 5 minutes? And then we'll just continue, because we're in time-wise, we're in good shape.
How do you know if your application is suitable for this? How do I just test it?
Okay, how do you run your current job, for example?
Sort of a bash script, shell script.
Just how many nodes do you use? One node? Use all the cores? Do you use all the cores on one node?
I just use it on my computer. I haven't even submitted it to HPC.
Okay. Do you have account?
No.
Okay, can you happy to? I think you should be fine. If you can run your desktop, why can't you use HPC? It's the same. Yeah, HPCs have just much more computing power. Yeah. And you can run one task here and let you run. I don't know how many cores. You can tell. If you do top, you can see how many cores being used. Do you know? I will show you here. I will show you here. Yeah. So you will see one task, how many cores it's using. If you're using only one core, that means it's a real serial task. If you use multiple cores, it's parallel already, but you still can use GNUParallel to submit. But would you have different input?
Yeah.
Okay, ideal.
A lot of different.
Ideal, yeah. You definitely need. How long does one task take on your desktop?
One task?
Yeah.
About 3 minutes.
Okay.
But
And then you have how many?
65 million.
Oh my. Yeah. You should. Which department are you from?
I'm technically in engineering.
Engineering, okay, good account. Start on Mike. You can also apply for Quimby.
I have no idea how to do it.
And for your application, you can install your own software.
So I can install my own software.
Yeah, you can install your own software.
And then this would just be able to task out different cores to.
Oh yeah.
It's a. I think for the most part, I believe it is a serial process. But it's just when I have.
Then then think about it on Super Mic. You could have 16 running at a time. If you apply for 10 nodes, that's 160 tasks at a time.
And they're isolated, so they're not gonna.
Yes, they cannot be talking to each other. That's the condition. Yeah. Yep. That's the condition. They have to be independent tasks. All right, let's resume. Okay. For this, use GNUParallel. Actually, for any of your production runs on HPC, you need to have thorough test before you start running, right? You cannot say, okay, I read a script, I'm going to submit it to my jobs. You're going to mess up, either with your CPU power, your allocation resource, or it's just not going to work, or just exit immediately. So you really need to do test. And for this, because basically you have three files. Your serial bash script, right, for your single test. And you have a job submission script to use GNUParallel, right? And the other one is your job list. Basically, you only have three files. And you need to test this. How do we go about testing? This is very important, not only for GNUParallel, for anything else as well. All right. First, the first step is test your serial task. And then you test your GNUParallel job, okay? We can do this all together, or I can just show you. All right, this is my job, my serial task script. What I'm going to do is, all right, here, I have requested 2 nodes, okay? Because I need to get ready for this training. But I'm gonna show you why. I'm not on head node. You can see it's a mic 061. I'm on a compute node. And I'm not SSH directly logging to that node. That's prohibited, okay, because I requested node right interactively. Oh, let me go back here. All right, let me just show you. Nope. Oh, here. I'm just gonna jump around a little bit. Now for testing, now I'm requested. How do you do request interactive nodes? QSUB -I interactive -a your allocation. For you, you need to apply for allocation, which is the currency for running your job on clusters. Not everybody can just come in to run their jobs. Yeah, okay. And then nodes. Oh, for this one, you could request for 1 node, 2 nodes, and wall time. That depends on your application, right? And then, okay, I'm going back to my session. I'll show you. Do you remember this one? I mentioned this is PBS, one of the PBS global variables. Once I interactively requested nodes, I requested for 2 nodes. I didn't show you the command. Request 2 nodes, and I'm automatically logged into the mother superior, the first node. Okay. Now I'm going to show you because now this variable is not empty anymore. Look, right? It holds information, mic 61 and mic 77. The 61 is the mother superior. Okay, so I'm sitting on mic 61, which is mother superior, right? So I have the information of the node file. Where am I? Okay, I am currently in, you should have this, you know how to get the source code, right? It's where you registered for this class, and the slides, also the source code I'm demonstrating here are all available there. So you would have all those files, all those folders as well. I have a blast of the information. Let's just take a look. What's in blast? I have a data. You know, all the input data, right? And also I have a blast DB. I have those, you know, blast, because when you blast something, you have to against the database. And then I have serial folder, which is the one we're going to talk about. I'm going to seed into that folder and see what's there. I have an input list. Oh, I want to show you actually. I'll just show you the beginning input list. Because you have this entire, all the source code. The reason I'm not using absolute path, I'm using relevant path, is for you guys to easy to use, because when you get all the folders, if I hard code my absolute path, you won't be able to run the task. So basically, what you want to do is input list back. You want something like this. You want absolute path for your tasks. So you know so your job will not get confused, okay? You always get the absolute path for each task. All right. Now, I can get rid of logs because I can output. Because I did a little test run this morning. All right, now you can see I have a run blast. This is my serial test script. Okay. All right, so first step, we need to test this serial task script. What do? Remember, I have a list, right? I'm going to substitute the. Oh, by the way, I have a README file there. In order to use this exercise, you need to load the blast key, right? If you look at here, I have a README file. Okay, in order to run examples, you need those keys on SuperMic, because those are system-wide installed software packages you need to load to your working environment. Okay. All right, now, what do I need to do? Okay, what I need to do actually, because I'm going to test, okay, I'm on the Mother Superior. I want to test whether my velocity P query, right? Basically, I want to test whether this line would work, right? This is for testing, right? You do want to submit, make sure all your commands or your lines are correct before you submit for production run. So query, and what is a query here? I'm going to get one from here, okay? Remember, GNUParallel will grab this one. I'll put it here. This is my input. And the rest, I need a blast db, which is this. Okay, let's just copy paste. And output. Oh, shoot. It only shows. That is bad. Output, I'm going to give it just for testing, right? I'm just test 10.out. I'm just typing it out, okay? And then the rest. Arrow 2 positional arguments. Oh, this is going to be interesting. I cannot really see what I typed in, right? What I can do is, though, I can open the editor and put my commands there, right? So that we can see it. Okay, I'm going to type that in. I just want to make sure, so I type everything in there. And I'm going to substitute with that, and db, okay, output is going to be just test 10.out. All right, I'm going to copy that thing. The reason I'm doing that is just now it's running. Actually, I should open another. This is on mic 61. I'm logging to mic 61. 061. Now I'm going to show you how to do top. When you get into that, you cannot randomly log into any nodes, only the nodes that you are assigned to, okay? You get into there, now look at this. Do top, and you can see one, okay, at the very beginning, there's top, 99%. There are 16 cores, can you see that? 0 to 15? And one core is being used because I only submit one job, one task. So it's working. It's doing blast right this second on this node, right? That means, okay, I just test my serial blast script. It works. All right, I'm moving on to the next. I'm going to kill this because I don't really need it, right? I'm going to kill it. And I'm going back to the same spot. You see? Now my node is idle now. There's no task running because I just killed it, okay? This is on mic 061, and this is where on mic 61 as well. I'm running because I'm on the Mother Superior node, okay? All right, so I just tested my serial code. Now I have this, okay, so this is another file. This is my job submission script. The very beginning, the top several lines is PBS directives. That means right now I don't need it because I am on a compute node already. I don't need to submit job. I have submitted job interactively, so I don't need those beginning several lines at all. But what I need is, okay, right now I'm testing how my GNUParallel script works. I'm going to do one line at a time. This is how you test your script. Okay, so here it says export that. I'm going to export it. Okay, and say CD to that. And I'm going to CD to that. And here next one is telling me to create those folders for output and the logs. Okay, -P means if they don't exist yet, do it. If they do exist, just ignore it. Now just take a look. I'm not going to take a look. Oh, it's fine. Take a look. So the log and output there, okay? And next one, I'm going to copy this, paste, execute this command. Export job per node. I'm going to ask GNUParallel to submit run 16 tasks on each node. And then my next line is this big GNUParallel with different options. I'm running this command. Okay, you cannot really see it. It's fine. If you don't believe it, you can do always echo. You can see that the parameter has been set as all that, right? That's to reflect what I just did. Okay, and then the next line would be running submit jobs. Okay, look at this one, what it's doing. Okay, to substitute parallel with all this long line, okay? And then my input file is -a, it's right there. It's sitting in this current directory, input.lst, and run my sequential, the serial task script. And then have a curly bracket, means grab the items from my input list. And I have two parameters because I need input and output. And I formatted the output format based on my input list. Okay, so each different jobs has corresponding output file name. I'm going to run this. All right, it's running. Now, look at this. How many jobs running? 16, right? So how you can find out how many cores for you, you just go to, you're just like laptop, right? Just top, open another terminal, top, and you can see if you're only using one core, you can only see one, maybe 90% usage, and the others all idle, 0 or 1. But look at this, I submitted 16, now 16 running. Actually, I have two nodes, right? I'm only logging to one node. If you log into the other slave node, 16 as well. So I have 32 blast jobs running at a time. And still, they're fully, because I have 1,000.
This is your mother superior.
This is my, you want me to log you into another one? Sure. No problem. Do you remember what's the other one?
71.
Is it? Okay.
70 something.
Was 71? Just try it. I mean, I'm taking a risk. No. No, you're bad. I'm looking at somebody say, okay, I need to, it's fine, it's fine. Here, do this. Qstat -u user, that's me, -n, show me the nodes. Okay, so it's 77. You are 6 off. All right, so 77. I'm going there, okay, the slave node. I'm there, see, 077. I'm doing top. Now look at that. So all the 2 nodes are 100% occupied. So I have 32 jobs running. Is that pretty amazing, right? Yeah. So this is how I'm doing this, is just to show you, you need to test your sequential job. You need to test your parallel job. This is how you do it. Use request inter-attic node 1 or 2, you know, 1 and 2 would be maximum. You don't need many to test, right? Okay, now we're going back to our slides. Okay, so step 1 to test your sequential task script. I did that, and then you test your GNUParallel script. I did that as well, and they work. Now you can submit. You can directly submit QSUB your job submission script, right? You don't have to do interactively anymore. All right, next one. So I have demonstrated how to parallel your serial tasks. Now the next one is, okay, you know, GNU Parallel not only can parallel serial tasks, and also parallel multi-threaded tasks as well. Okay, and for the for the BLAST P, actually, it, you know, this application itself is a parallel application, because you can specify however many threads you want to use. Okay, it could be up to 16. From 1, before I was using 1, you remember the last parameter there, number of threads. This is application itself has different parameters to tell the BLAST P, you know, how many threads to run for a single task. All right, so I'm going to demonstrate this one. Okay, this is my for multi-thread BLAST task, and this is my the single task script. The difference, pretty much everything else is the same. Okay, it's a BLAST P query $1. You pass in your item from the input list, and the database is the same. Output $2 is the same. And then you have all the other parameters for your BLAST run, okay? And I pass in another parameter, $3, which, you know, to tell the BLAST to run, to use how many threads. Before, for the serial version, I just hard code 1 there, means just 1 core, okay? But here I pass in as a parameter. Now, if you look at this job submission script, you know, PBS directives, oh, I all have that. It really bothers me. I think what I did is, initially I have all that spelled out, and somehow I changed it. All right, so now export my work directory and CD to my work directory, all the same, and export jobs per node. I'm doing 8. Before I was running 16, because right now I want to do threads. I want to do 2 threads for each task. I only have 16 cores, so I cannot run 16. That's overloading. You could, but it's not good. Okay, so basically I run 8 jobs. However, for each job I use 2 threads. And then all the parallel define this parameter, parallel variable stays all the same. There's no change, exactly same. Now look at the last line. Parallel input is still the same. And then run this task. Of course, right now you are in different folder, right? Directory. The file name still stays same, but the content is different. Output still is the same. However, I have one extra parameter, and this one is the threads number. So that right now I define as 2. Could be 4. It's up to you. Okay. If it's 4 there, then you have to change jobs per node as 4. You only have 16 cores all total. And this is how you do it. So the only difference of these two is I have 3 parameters for the single task because I'm passing how many threads I want to use. Okay, is it clear?
So how do you determine the number of threads you want to use?
That's because you know the application. It's up to you, right? You could say that I want to, sometimes you can do some testing just to see whether you use one core and longer time. Think about it, 1 core will be longer, right? Use 2 core, gonna be shorter. However, it's not really proportional. If you use 8 threads, and the time of completion may not be only 1.
So here the threads mean the nodes?
The cores. The cores. Remember when my serial task, I only use 1 core, right? But right now, I don't want to run this. You will see one single task would be taking 2 cores. 2 cores would be like 90%. Yeah. It's just up to you because, up to your application. Sometimes you have that sweet spot. I use, 4 cores or 8 cores, that my job would be using, running really efficient, short time. But it's not always, I've used 16 cores. My task may not only use 1/16 of the completion time compared to a single core task. So
I presume you have to balance that against your allocation, right?
Not really, because you have 1,000 jobs, for example, 1,000 tasks, right? You're gonna.
So it's core independent.
Yeah, it's core. No, the application is not. No. How to calculate your SUs? When you apply for allocation, right? You apply for 1 million SUs. 1 SU equivalent to 1 hour, 1 core. That's how, yeah. If you use, for example, if you applied for 2 nodes and you only use 50% of the cores, you are charged for 16 times 2, that much time, even though you are not using all those resources. So that's your waste.
So here you mentioned that you need 2 nodes and 16, which is 32 cores, right?
32 cores, yes.
Yeah, but you are using only 16 cores here.
I am talking about this jobs per node.
So 82.
So I have, for each node, I have 8 jobs. For 2, I have 16 jobs. If you apply for 10 nodes, you would have 80. For each node, you have 8 tasks running, and you have 10, you would have 80. Right? Yeah. All right, the last one, MPI jobs. MPI jobs, you may not know what MPI job, it's just because there are different labs are using their applications are written in MPIs. MPIs basically, one single application can run on multiple nodes. Serial task only run on 1 node, 1 core. But multi-thread tasks can run on single 1 node, multiple cores. But MPI jobs can run on multiple nodes. Their communication, yeah, that's just, it's designed that way. So I'm going to talk about as a last example. All right, look at how simple it is. MPI run, because you need to load the MPI implementation software package to your working environment. For this one, I'm using NemD. Heard about NemD? NemD is molecular dynamic application. NemD2. Okay, it's for chemistry or biology, and maybe, I don't know. Yeah, but anyway, this application, the third example is using NAMD. Okay, NAMD, that's the name of the application. So look at my serial job submission script. It's so simple. Okay, MPI run, that's the command, how to run MPI jobs. -NP means how many processes you want to launch. Okay, you don't have to understand this, how this software being used. They just understand how this works with GNUParallel. And which NAMD2, that means give me the application name. NAMD requires doing this way. And then I have 3 parameters. Parameter 1, 2, and I'm outputting, okay, redirect output to $3. You can do that. You might want to do that, right? Instead of either way, yeah. This greater sign can be used as a redirect output, because a lot of applications are designed the output goes to the screen, right? When you want to collect the output from the screen, you have to redirect to another file so you can collect that information. All right, so this is job submission script. The beginning, all the same. I still have the work directory there. Wrong. All right, export. I'm going to run jobs per node as 2 again. And the number of process, now I have 8. Okay, for each task, I'm going to launch 8 MPI processes. Then define the variable parallel, jobs per node, file name, node machine name, work directory, job log, resume. Stay the same. And the last line, parallel, my input, this input is going to be, look at this input. I'm not going to show you how to generate the input file for an MD. That's a totally different story. It's complicated. But anyway, the input file is there ready, right? If you are running MD, you will know how to generate the input file. So it's there. So my input list, and I'm going to run my serial task script, run md.sh. And a curly bracket means grab one input, put there as the first parameter. And the second parameter would be how many processes I want to run for my MPI job. It's over there defined as 8, my output. Because this is a log file. I'm capturing whatever print out to the screen into a log file. I put into here. So basically, this runMD.sh has 3 parameters. If I go back, see, I have 3 parameters. Okay, they have to match, definitely, right? Otherwise, it's not going to work. And the same thing, you are going to test the serial task and the parallel task. Yeah, you do the test before you really start crunching your data. Apply for 10 nodes, 20 nodes, however nodes. Okay, we're reaching to the end. GNUParallel, how the GNUParallel does is it start job. Okay, you have 4 CPUs. I'm going to show the graph later. So basically, starts next job once the previous job is done. Okay, keep all the CPUs busy, all the cores busy. All right, this is GNUParallel. I have 4 CPUs. Okay, I have 4 CPUs, and the GNUParallel would give job 1, job 2, job 3, job 4 to different CPUs. Once the job 1 is done, oh, the first one would be the job 4, right? Oh, the job 2 is done, and then submit another job to the second CPU. Okay, so GNUParallel will try to keep all the CPUs busy at all time. And at the very end, when you run to the very end, there always happens that you only have 2 tasks remaining. For example, you have four CPUs requested, and then the 2 would be idle. It is, because you request for 2 nodes, and only 2 last the job is still crunching, still running. So you would have 2 CPUs idle. But however, the wait time is really tiny, okay? Now look at this one. If there's no load balance, you are going to end up with a lot of waste. So all the other 3 CPUs idle, trying to let this CPU finish the task. That's the one without load balancing. That's the one, for example, you want to put all the tasks into background. That would be the case. So GNUParallel has the feature to balance the load, so to minimize the CPU waste, basically. So which is really cool. All right, the last slide's conclusion. GNUParallel, I guess by far, you could see that it's quite effective and it's really relatively easy to use, to learn, and the learning curve is not deep at all. And keep in mind, GNUParallel only parallel independent tasks, right? So same application, or can be different applications, but no matter what, you have different input. All the tasks are not talking to each other. They're all independent. Okay. Of course, in most cases, if you have the same application with different input parameters, that's that applies for most users, I think. You would want to run different applications through different jobs, right? You wouldn't want to mix them together, although you could. So the type of applications that you can use GNUParallel could be real serial task using one core. That is defined as serial task using on one core. Or it could use application use multiple cores. The application actually is parallelized already, but only use multiple cores within one node. Okay, cannot jump to different nodes. Or you can even use GNUParallel to parallelize your MPI jobs. Okay, each MPI jobs can run on multiple nodes. On multiple nodes, you can, maybe your single MPI jobs want to run on 2 nodes, but it only runs on 4 cores on each node. So basically, you can run 4 MPI tasks on 2 nodes, right? You don't want to waste you only use 4 cores, you still have 12 cores left, so you can fit in 3 other jobs. However, there are some, I have to be wise, to be cautious when you use GNUParallel. Remember, GNUParallel is the mother superior established SSH connections to each slave nodes. If you have applied, when I was doing that graph, you remember the GNUParallel performance comparison? I request up to 64 nodes. Can you imagine how many SS connections from the mother superior to the 3 other slave nodes? It's a lot, right? It's a lot of overhead for the mother superior. So, and also if you have a lot of input file, write file or read file, so be careful. You don't want to have too much overhead. So you may want to consider not using 64, maybe 10, maybe 20, but not. Unless your task is really straightforward, you're not opening or closing or writing too many files at the same time. Yeah, so that's why too many SS connections from the mother superior. That's one restriction you have to consider. And also, if you have requested for 64 nodes, for example, and each of your tasks takes 2 hours on average to finish, right? And at the very end, not 2 hours, let's say 4 hours. At the very end, and you have 3 tasks left, all right, on 3 different nodes, then that means 61 other nodes are going to wait to be idle, to wait for the 3 nodes to finish. So that's going to be a lot of waste as well. Unless each task takes really short time to finish, so the idle time is short, it's okay. But if it takes 10 hours for each task, you do not want to apply for 64 nodes, right? There will be a long idle time at the very end.
But in that case, you can use API.
MPI? MPI is only the applications written in MPI. Yeah, it's not if your application is not written in MPI, you cannot run MPI. Yeah, it's a different issue. So when you use GNUParallel, because shows how many nodes you want to apply. Okay, just because you need to know what's going on under the hood, so you know you are not going to oversubscribe the system. And the last one is thorough testing before you start your production runs. Yeah, that applies to GNUParallel. It also applies to any other application as well. So with that, I'm going to conclude today's tutorial, and keep in mind we still have other tutorials going throughout the rest of the semester. So if any of those topics you're interested, just go to register. Okay, any questions for today's GNUParallel training? And you have the source code, you can play with it. Any questions in the future, you can always give us questions, submit a ticket or call us.
What about consulting?
Be more specific.
Like just advice on how to proceed if I wanted to use.
Come on in, yes, set up appointment. Yes, we do that too. Yep, definitely. But sometimes it's hard to just, communicate through a ticket, because we have ticketing system, right? You submit ticket and we'll answer questions. But sometimes it's easier just, okay, just come in, we sit down, we'll look at your code and see what the problem is. Yeah. Or what do you want to do? How do I get there? Yeah. Yes, yes. Yes, how to get there. Yes, absolutely. Just contact us and I will set appointment. Mm-hmm. Okay, I need to stop recording.